Okay, we're almost done. So, if you plug in your numbers, you get 9.87 minus 10.17 divided by your standard error of 2.443. And you get a final t-score of 1.228. Okay? Again, it ends up being negative if you subtract the means in this way, but it doesn't really matter. You just want to get the difference between the two. Now, you have your t-score of 1.228. Go to your Appendix C called the distribution of t. And if you have the paperback version of the textbook, it should be on page 497. Now, the table for the distribution of t is actually a little bit complicated. So, if you look along the top of the table on page 497, you'll see there's level of significance for a one-tailed t-test and a two-tailed test. Now remember, way back when, we just wanted to see if there was a difference between the males and the females. Okay? So, because I'm just asking for a difference and not if one is specifically bigger than the other, then we're going to do a level of use the level of significance for a two-tailed test. Okay? Now, you want to look, I've kind of recreated a portion of this table on the board here. You want to look at, first of all, your degrees of freedom. Remember, our degrees of freedom is 225. Okay? N1 plus N2 minus 2, or 225. That means we're going to use the infinity symbol. Because if you look at your distribution of t table, you can see on the left-hand side your degrees of freedom, and it goes over onto page 498. Starts at 1 and goes all the way down to 120. Okay? Anytime you have a sample size that yields a degrees of freedom over 120, you're going to use that infinity symbol. Okay? And that applies to this particular problem because our degrees of freedom, it's obviously over 120. It's 225. Okay? So that means we're going to look at our levels of significance. Now you read this table a bit differently, or quite a bit differently, than the standard normal table. So our levels of significance, our thresholds, are across the top. And in your book it lists from 0.20 to 0.10, 0.05, 0.02, 0.01, and 0.001. We're just going to use 0.05 and 0.01, which is what's most commonly used in the research. So I've written those in green. Okay, so our final t-score is 1.228. Then we go to our degrees of freedom, the infinity symbol we're using, and we want to look at it across, going from left to right. In order to see if there's a difference between our means at the level of 0.05, we need a t-score of at least 1.960 or higher. Okay? If the difference between the two means were significant at the level of 0.01, you would need a t-score of 2.576 or higher. Okay? Now our t-score is 1.228, which means it's not significant at the level of 0.05. Therefore, we accept the null hypothesis. Okay? And we see that even though there are mean differences between the males and females in the sample, the girls scored 10.17 years. That was their average age they first tried smoking cigarettes, and for the boys it was 9.87 years. There are observed differences. Okay? But what we find is that those differences are just due to chance. Okay? And they're not significantly different from each other, neither at the level of 0.05, and if they're not different at 0.05, they're certainly not going to be different at the level of 0.01. So we accept the null hypothesis and say, with regard to average age that boys and girls started smoking in this sample, they're basically the same. Okay? And the differences we see are only due to chance.